It's time for another amazing chemistry video with Mr. Stapleton. Proud to sponsor by finding a nice coffee.
Hi guys, welcome to this video, which will probably be a reasonably short one today, but I'm just going to be introducing all about amino acids for you, purely from a chemistry viewpoint. So I'm not going to be going into a lot of the biology of it. I'm just going to be talking a little bit about what you need to know with regards to Year 12 chemistry. So what you need to know firstly is that all amino acids have the same general structure, and this is what we're concerned about in chemistry. So what you've got is a central carbon atom, okay? And that central carbon atom has two functional groups coming off either side. On one side, it's got a carboxylic acid functional group, okay? And on the other side, it has an amine functional group, NH2, okay? Then the only thing that's different is all of them have a hydrogen attached to them, and then they have this R group here. All right. Now that R group, okay, can vary. There are 20 different forms. All right, 20 variations of our R group. All right, that means there's 20 different amino acids. It can be as simple as a hydrogen or a methyl group, or you can start having more complex chains. And those side chains really come into play when you're talking about the tertiary structure of a protein, which will be in another video where we're talking about the different, 4 different structure types of a protein. But that side chain is what determines the tertiary structure, and you get a lot of hydrogen bonding, you get some non-polar covalent bonding, you get some ion dipole interaction occurring there as well. So this is your general structure of your amino acid, and it's really important that you can be able to draw this. Now, hopefully, if you've been able to identify the two functional groups of carboxylic acid and amine and have enough of an understanding, hopefully you'll be able to remember, or you'll know, that the carboxylic acid amine group is, of course, acidic, and the amine group is basic. Now, obviously, an acid reacts with the base, so you can actually get an amino acid reacting with itself. And when you do that, you actually get this unique molecule here. Alright, so you still have your central carbon atom, you still have your R group and your hydrogen, but this time an acid is a proton donor. So what happens is that the carboxylic acid functional group actually donates a proton, so that becomes O-. And the amine over here actually accepts a proton, so the hydrogen goes from one side to the other, and you end up with a nitrogen with a positive charge on it and an oxygen with a negative charge. Alright, this is what we call self-ionized. So the carboxylic acid has reacted with itself and formed ions. Right? Now this is one of the reasons why amino acids are so soluble in water. I mean, you have these two polar functional groups here, which even on their own will be able to hydrogen bond with water. But because you can self-ionize, you can now get ion dipole interactions occurring between the amino acid and the water, so they're always really soluble. It's also the reason they have really high melting points, so all amino acids tend to exist as crystalline solids at room temperature, because you get lots of interaction occurring between either the hydrogens on here forming hydrogen bonds, or the amines over here forming hydrogen bonds, or the ion dipole interactions you can get happening over here as well. Now the term that we use for this is Zwitterion. So Zwitterion is a self-ionized amino acid, okay, which is where you get the hydrogen from the carboxylic acid group going over and protonating onto the amine. Alright, so that's all I'm going to talk about with amino acids. I'm going to lead this into the next video where I'm going to talk about proteins, and in particular I'm going to talk about the 4 different structure types of proteins. So if you can get an understanding of the general structure of an amino acid, okay, you can draw that, you can understand that it's got a carboxylic acid functional group here on one end, an amine group on the other end, that they can react because one's basic, one's acidic. You can get this Zwitterion or self-ionized form of the molecule occurring, okay, which accounts for its high solubility in water and its high melting point. Alright, hope this has been helpful. As always, if you've got any questions, just ask. Thanks guys.